Okay, so I'm gonna practice some of like the problems that can help you out with basically everything about rational functions, which is this type of problem. We're given a graph, and in this case, they're already giving us, we don't have to figure it out, they're already giving us the vertical asymptotes. And we're given the horizontal asymptote. We're given, in this case, we're told there's not x-intercepts, which could also be interpreted as zeros or roots. And it passes through the point 0, 1. This is important, okay? Especially when we have a horizontal asymptote which equals to 0. That's important. Whenever you have a horizontal asymptote equals to 0, we'll have to do something special with the a, okay? But okay, I'm getting ahead of myself. Okay, so how can we know which one of these options to choose? Let's see each one. Okay, so for this one, we know that we're given something like, so what we have up here, remember when we have a rational function, how can we get everything? We know that we can get the zeros from the upper equation that we have in the function on the fraction, and the downside we can get the vertical asymptotes, right? And we know that having the degree of each x can give us the horizontal asymptote, right? Okay, so having this in mind, we know that if there is no zeros, it can either be something like this with just one, depends on how many vertical asymptotes you have, or it could be something like this, with also depending. Okay, so which one will we choose? Well, if we're not given any empty dot, we're gonna go with the a alone, okay? And now, how can we know then which one? So we know there's no zeros, so it can be either this one, and there's no empty dot, so it can be either this one or this one, right? Now we have closed the answer with two options, okay? How can we know what to put underneath it? It's easy. We're gonna see how many vertical symptoms we're given. Okay, so we're given 2. So in this case, since we're given 2, it's gonna be 2 parentheses. So it's gonna be this one. Okay, perfect. So now that we know that it's this one, as I said, since we're not given the horizontal, like we're given a horizontal asymptote as y equals to 0, it's really hard to figure out what the value of a is gonna be, right? So how can we figure it out? Well, that's why we're given a point. We can evaluate in that point and solve for a. Okay, we can solve for a. Okay, let me just erase. Okay, so we already know that's this one. And since we already given the vertical asymptotes, we know that this transforms to x minus 1, and this transforms to x plus 5, right? Remember, because since it's going to be usually how we get the vertical asymptotes is that we equal whatever's underneath to 0, and we solve for x, and in this case, if we solve for x, we're going to get x equals to 1 and x equals to negative 5, okay? So it's the inverted form, like you have to do it inverse, the process inverse, okay? And now we're still missing the a, right? So we know that this is a function, right? This is a function. And we know that this function, evaluated in 0, it's going to give me 1. So what can we do with this data? Well, we just evaluate it here, this 0, and solve for a. So what do I mean by that? We're going to do a. Remember the a, we don't move the a. The a, we don't change value. We're going to get that value like solving for it. So x equals to 0. And if we solve for a, and then now that we evaluated, we know that this evaluating 0 is going to give us 1, right? So we use this to get A. So first, we simplify. So this is -1 times 5. And then we've got to get rid of A, right? So if here is dividing, we pass it multiplying. So A equals to -5. Okay? So now that we have value of A, we just replace it here. And that's our function. -5, x minus 1, x plus 5. Okay? So now let's see another example. Let's say, okay, I actually have one for this type of problem. So for this type of problem, we're going to be given 1, 0, and 1 vertical asymptote, and probably a horizontal asymptote. Because we have the same degree of these x's, so we know in the end a horizontal asymptote is going to be something divided by something, right? Okay, so let's look for that example, this one. Okay, so for this case, we're going to get the values. We know here is a 0. Remember, whenever there's an x-intercept, that's a 0. So we know that we have something like this, right? This is going to be x equals to 4, right? Which is a 0. Okay, it's 4, 0. Okay? And then we have a y-intercept, which we could put it as a dot. Okay, so we know that in the graph, it passes through the point 0, -2. Okay, so whenever the function it's evaluating 0, the answer is going to be -2. Okay, so that's important. This is a point. Something important also is the vertical asymptotes. We have just one, which is -4, which will be translated as x plus 4. And we have a horizontal asymptote, which is 2, right? Y equals to 2. This one will be important when we want to get the A, okay? So in this case, we just have one vertical asymptote and we have 1, 0. So what's it going to be? It's going to be the constant, it's always there, 1, 0, which the 0 is at 4, so it's going to be x minus 4, divided by how many vertical asymptotes we have? Just one, which is x plus 4, right? And now, how can we get the A? In here, we have two options. We can do the same as the last problem. We evaluate with 0 and solve for A. Or we can just look at the horizontal asymptote. It's 2, right? So we know this is going to be just going to have 1. So it's going to be technically, we can just go like this. 2x minus 4 equals to x minus 4. And we can verify that this is correct because if we evaluate in 0, let's go 2, 0 minus 4, 0 minus 4, we're going to get -2. Let me just show you. So it's 2 times -4 divided by 4. So it's -8 divided by 4, which is -2. So that's how we can verify that this function is correct. Okay? So that's an example of this type of problem. The only difference of the other one, let's say we are not given a 0. Let's say this goes like that. Then it will be something like, technically, I think the horizontal asymptote will be here. It will be y equals to 0 because it never touches the x-axis. So in this case, this is when we will use the equation of A divided by the only vertical asymptote that we have, which is x minus 4. And, plus 4. So we're going to have this answer, right? And how can we get A? It will be the same. We have to solve for A because the horizontal asymptote doesn't help out that much. So we know that the function evaluating 0 is equals to 2. So technically we just have to do a divided by 0 plus 4 equals to 2. And then we just multiply. So in this case, a equals to 8. So the formula will be 8x plus 4. And if we evaluate 0, oh sorry, let's say this was plus. Well, no, we can leave it in negative. It's just going to be this. There you go. So, oh no, ignore that. So now we know that if we evaluate, yes, negative 8. If we evaluate in 0, it's going to give us negative 2. So we know that's correct. Okay, so I'm just going to show you. Negative 8, 0 plus 4 equals negative 8 divided by 4, which equals negative 2. Okay, what else? So we already showed this example whenever we don't have any zeros. And now let's look at one where we do have a 0 and we just have two vertical asymptotes. Okay, I think we have one right here. Okay, so in this case, we are given, oh, this one's actually more interesting because we're given two intercepts. Okay, so that changes. It's not going to be an example of this one. It's going to be an example of this one. Why? Because we have two x-intercepts. And what did I tell you that the x-intercepts are? Are the zeros, which we get on the upper side of the fraction, and we get the vertical asymptotes on the downside of the fraction, right? So we have two zeros, it's going to be two parentheses, okay? And well, a and two parentheses, okay? And how many vertical asymptotes we have? Well, in this case we have two, so it's going to be two parentheses, right? So that gives us this, correct? They're the same, right? If we were to only have 1 0, then it will be this example, okay? But we have two zeros, so it's this one. Okay, so how can I solve this one? The good thing about this one is that we have a y-intercept, a value that's not 0. So in the end, this one is probably going to be a. So it's probably a going to be minus 2. We'll just verify that later. Okay. So we're given that we have x minus 3, x 6. So that translates to x plus 3, x minus 6. And we're given two zeros, which translates as x minus 2. So I get the positive. And x plus 4. Right? Okay. And we have an a. Right? So we're almost finished. We just gotta verify that if we put negative 2 here in this a, we're gonna get this point if we evaluate in negative 2. What do I mean by that? Well, let's just put here the negative 2. If I do this, function of negative 2, so I do negative 2 times whatever the x is, I replace it by negative 2 times negative 2 plus 4 times negative 2 plus 3, negative 2 minus 6. So this translates to negative 2 times negative 4 times positive 2 divided by negative 1 times negative 8. So it's going to be, if we simplify it more, it's going to be negative 2 times negative 4, positive 8 times positive 2, positive 16, and negative 8 times negative 1. Oh, sorry. This was actually positive. Okay. So negative 8 times positive 1, it's going to be negative 8. And if we do this, it's going to be negative 2. There it is. It's correct. So we have our function. It's this one. Okay. And so yeah, that's so I'm just gonna make a quick summary. I'm not gonna show you of empty dots. I'm not gonna put something like that in the exam, to be honest. But I'm just gonna make here. Okay. So Pepe actually shared something like this. So for this one is whenever we have no zeros slash x-intercepts, and we just have one vertical asymptote. Okay. This one is when we have 1 0 and one vertical asymptote. This one is when we have no zeros and two vertical asymptotes. This one is when we have 1 0 and two vertical asymptotes. And this one, lastly, is when we have two zeros and two vertical asymptotes. Okay? If we were to have an empty dot, then the empty dot will be either this one or this one, depending if we have zeros or we don't have any zeros. So if we don't have any zeros, but we have like one vertical, so in this case, if we were to have an empty dot, so let's say we have an empty dot, then it will be this one, and we'll have just one vertical asymptote, because remember the way we get the empty dot is that one eliminates with the other. So technically we will just have one vertical asymptote, right? So that's when we have an empty dot, no zeros, and one vertical asymptote. This one is when we have an empty dot, and we have, yeah, so let's say we have the empty dot, so it deletes. Technically we have this, and we have, so they tell you there's an empty dot, there's one vertical asymptote, and there's 1 0. Okay, that's the only case we could have as an option. So yeah, if you have any questions, let me know. But regarding this type of problems, it's this video.